Hi, welcome back. So we're at the outline on converting one-dimension array into two-dimension array. The basic idea actually starts if we would have this simple array with one dimension, as we know so far. It's just a list with one dimension that have 5 variables, or you could also consider each one as a dimensional entry or element. Now, if we want to convert this into 2 dimension, the simple way to do that by defining a variable, for example, here array2, which is going to be the array as 1 dimension, open brackets into 2 argument. In the first one, function in new axes, and then this column indicate the entire array. So we're going to deal with this. And then I created another one, taken as well the same exact array, the original one, but this time I started with a colon and then comma np.newAxis. Let me just print the first 2 arguments and see what the result looks like. See here in the first one, array2, it created actually a 2-dimension array, which we can see here, and the shape of this array, which is I printed here, 1 row by 5 columns. I think if you read this carefully, you will understand that we created the axis by row wise. So we've got here 1 row, we used all the elements, whereby on the second array, now we are working as a column wise, become 2-dimension, 5 rows, 1 column. Beside that, I could have used alternative method, which we have got to use something called expand dimension function, which expect actually 2 arguments. In the first one, expect array that you have in 1 dimension, and on the second argument is asking you would like me to do row wise or column wise. So in this case, as 1, it means a column wise. Print this activation. I should expect to get this one identical to the array 3 that we have created with shape 5 by 1. However, if I change the axis into 0, I should expect to get identical to the first one, which is shape 1 by 5. Now the next thing maybe we want to talk about is indexing and slicing, which doesn't differ much from the Python list, where if I would have the original array in 1 dimension like so, I could reach any of these indexes just by defining the array name and the index that I'm interested to reach to. For example, here the first index or index 0, which return the value of 1. Also, I could use the column to indicate slicing the array. For example, I start from the first index all the way to the second, so I return the first and the second value as we could see in here. Of course, 2 won't be included, so I could return 0 and 1. Or I could, starting from the first all the way to the end, or I could start working with the index back from the end. So here, start from the second index all the way to the end of the array. Also, you might want to have some operation on the array directly. For example, this is a tensor. You want to retrieve all the values that are less than 5 from the array, and then I make my condition and say I want all the values in array that are less than 5. Print the result. I could get array back in 1 dimension, including all the values that match the exact same condition. Also, I could do maybe some kind of selection on the list. For example, I would like to select all the element or the value that are divided by 2. So if I want to print this one, I get all the result retrieved as the condition have been met. In addition to that, you can also select element that satisfy 2 conditions using the and the or. For example, larger than 2, less than 6. To print this, you will get the result as expected. All the values here have met the condition. Now you can also use something called the np non-zero to select elements or indices from an array, and this non-zero function asks you to perform the condition. So in this case, let's say for example I'm going to get into condition where a less than 5, so the result is returned here as 2 tuples present the rows indices and the other one column indices where the value is found. Here we've got on the row 0 on the first column, this value match the condition that we said a is less than 5, and the result is true. Actually, I could create, instead of just reading like that, a kind of a coordinate where the values are. So what I could do, I'm going to use the zip function, the 0 index and the first index from the tuple. Let's go ahead and print actually this. And as we expected at the 0, 0, which is in here, the value at the 0, 1, which is in here, and so on and so forth. Also, maybe you want to print the values just by actually printing array of A that has been defined as the B0. So, and you will get the result. Next, actually, we'll be working on how to create an array from existing data. I will see you then.